Test number 6. Title is Direct Current Circuits. Question number 1 is related to connecting resistors in such a way that the total resistance is smaller than the least individual resistance. Given example involving 3 resistors. So what I'm looking for here, number 1, if you connect them in parallel, it's going to be smaller than the smallest individual resistors. So I was looking for some kind of a numeric demonstration of it, and most of you guys did not provide that complete explanation in the numeric format. So give an example, meaning that, hey, make one resistor 1 ohm, the second one is 2 ohms, the third one is going to be 3 ohms, and then when you actually sum them up reciprocally, you will notice that the overall resistance is going to be smaller than the smaller resistance value that you have. So I was looking for a bit of a numeric demonstration of it. Question number 2, this time you connect all of them in such a way that the overall resistance is going to be larger than the largest resistance value that you have. In this case, you have to connect them in series, obviously. So the first resistor is going to be 1 ohm, the second one is 2 ohms, the third one is going to be 3 ohms. Add them together, so it's going to be 6 ohms. It's still going to be larger than the largest resistance of a resistor that you have. Question number 3, why is it possible for a bird to sit on a high voltage wire without being electrocuted? There are 2 reasons for it. One reason is the step potential on the wire, which depends on the distance between the contact points. And obviously the distance between the contact points for a bird is fairly small, so the potential difference between those 2 contact points is relatively small. On top of that, the bird is parallel to the wire, so the resistance offered by the body of the bird is much higher than the resistance offered by the wire itself. So the current, given a choice, is going to remain in the wire because the bird is parallel to the wire. So there's still current going through the bird, but it's not large enough to be noticeable because the bird's body offers a lot more resistance. And some of you guys, I don't think anyone really covered both of them. Like, it's a step potential thing, which depends on the distance between the contact points. Some of you guys think that there's no potential difference. That's not correct. If there's any sort of separation distance, there's going to be a potential difference, but the potential difference is extremely small between the contact points. Also, the fact that the bird's body is parallel to the wire, and the body offers a lot more resistance than the wire does. I was looking for a complete explanation for it, and I think one person may have provided it. Most of you guys didn't really get to that point. All right, so question number 4 is about a short circuit. But this is the short circuit in this case is like grounding the device. It's the same thing. It's a path of very low resistance in a circuit in parallel with some part of the circuit. Discuss the effect of a short circuit on the portion of the circuit in parallel. So you gotta remember that short circuit will be a circuit that becomes parallel. It's a wire that becomes parallel to the main circuit that you're looking at. Use a dryer with a loose internal wire touching the metal casing as an example. So that's something that we discussed in class. All right, if there's a loose wire touching the inside of the metal, the electrolyzer will be repelled to the surface, so which means that the current is going to reside on the outside. And if there is a grounding wire, which means that the current is going to be taken directly into the ground. So if you come in contact with that circuit, with that casing, without the grounding wire in effect, that current, you would become part of that circuit, which means that the current would be forced to go through your body to get to the ground. And because that grounding wire is there, when you come in contact with the circuit externally, now the current has a choice to get to the ground using that parallel wire. And that wire would be parallel to your body. So it's exactly similar to the reason why the bird sitting on a high voltage wire does not get electrocuted, because your body offers a lot more resistance than the grounding wire does. So despite the fact that a little bit of current is going to go through your body, you're not going to notice it and it's not going to cause any harm. So that's the sort of explanation that I was looking for. Question number 5. If electrical power is transmitted over long distances, the resistance of the wire becomes significant. You know, the resistance of wire is going to become significant because larger the resistance is, more of that power is going to be lost in the form of heat. So which means that power is going to dissipate in the form of heat. All right, so if power gets dissipated in the form of heat, not much of power is going to be available for the consumer at the end of the road. So that's what the problem is. So which method of transmission would result in less energy wasted? High current and low voltage, or low current and high voltage? And explain your answer. Well, the short answer is you want to keep the voltage as high as possible. You want to keep the current as low as possible. Now you have to justify an explanation for it. All right, so regardless of resistance of the wire is going to be the same. The resistance is going to be related to the length. It's going to be related to the thickness. So it depends on the geometry. So you cannot change the resistance. So if you actually transfer the power in the form of current, a lot of that power is going to be lost in the form of heat. All right. So the formula to look at is going to be V squared divided by R. The resistance is not going to change. Obviously, that's a constant. So bigger the voltage is, the more power is going to be actually transferred in this case. So you're not really losing power in this case. So you're transferring it. In this case, you're only transferring energy. That's what it means. All right, so the power is going to be transferred in the form of the electric field. All right, that's what happens. So which means that you're not going to end up losing anything in the form of dissipation of power in the form of heat.